this lesson, we are going to learn how to graph simple rational functions. So remember that when we talk about rational functions, we're talking about fractions. The parent function is y equals 1 over x. And we learned in the last lesson what that function looks like. So if you recall, the parent function is centered at 0, 0. It has a horizontal asymptote and it has a vertical asymptote. And one of the critical points on either side of this function is over 1, up 1, and over 1, down 1. Now that's what the parent function looks like. In this lesson, we're going to learn how to shift that function up, down, left, right, and stretch it out. So you may recall from some of our previous lessons that the constant with x is what's going to shift your graph left and right. For example, if you had x plus 3 in the denominator, that's going to shift your entire graph to the left 3. Whereas if you had x minus 3, that's going to shift your entire graph to the right 3. The constant at the very end of your function, remember, is what moves your graph up and down. So if you had something like 1 over x and a plus 3 at the end, that's going to move the whole thing up 3. But if you had a minus 3 at the very end, it's going to move your graph down 3. So the constant shifted up, down, left, and right. The value at the top of your fraction, your a value, this is going to be the number that will either stretch or reflect your graph. So if you've got something like 3 over x, it's going to stretch your graph out. A reflection would happen if you have a negative thrown in there. So if you have something like negative 1 over x, it's just going to flip your graph over to the other side. So let's see what some of these look like. So for each one of these functions, we are going to identify the asymptotes and then write the equation of the function. So on example number 1, you can see the vertical asymptote right here. It's going through the x-axis at 2. So the vertical asymptote is x equals 2. We can also see the horizontal asymptote labeled here. It's going through the y-axis at 1, so that equation is y equals 1. Now the reason why we want to start with the asymptotes is this helps us understand which way our graph has shifted. Instead of being centered at 0, 0 like the parent function is, this one has shifted to the right 2 and up 1. So when I write my equation, it's going to be y equals 1 over x minus 2, and an up 1 would be a plus 1 at the end. So the x minus 2 is what shifts it to the right 2, and the plus 1 at the end is what makes it shift up 1. Now I didn't have to worry about changing that 1 on the top, because if you notice the points in green, from the center of this graph, you go over 1, up 1, and you hit that green point. So it has not been stretched out in any way. Let's try example number 2. So we're going to look at the vertical asymptote first. We see the vertical asymptote passes through the x-axis at -3. So this is x equals -3. The horizontal asymptote we see crosses through the y-axis at -2. So this is y equals -2. And the reason why I identify that is it helps me see which way my graph has shifted. So it has shifted, instead of being centered at the origin, it shifted to the left 3 and down 2. So I understand that there I would be doing 1 over x plus 3 to go to the left 3, and then a minus 2 at the back to make it move down 2. Now I do want to double check the green points, because what's normal is to go over 1, up 1. This one doesn't go over 1 from the center here, from the cross section. It doesn't go over 1, up 1. It goes over 1, down 1, which indicates that we need to be using a negative here. It's been flipped over. In fact, if you compare this function to example number 1, you can see that those curves are on the opposite side. It's been flipped over. Example number 3, vertical asymptote. The vertical asymptote is passing right through 0, so x equals 0. And the horizontal asymptote is also passing right through 0, so that's y equals 0, which tells me we haven't shifted up or down or left or right, so I don't need to put anything down here with x or anything out to the side. If I wanted to, I could put, like x plus 0 here and a plus 0 at the back. It's just not necessary to do that because those are zeros. So the number I'm really concerned about is the numerator. I want to know how much has this function been stretched out. So remember, the parent function from the center goes over 1, up 1. I want to know, how is this function different? So look at the green point. Instead of going over 1, up 1, it goes over 1, up 2. It's twice as much as the parent function, so I'm going to have a 2 on top. So really, this would just be written as 2 over